So first of all, press your menu button. My menu graph is option number 5, but I think for you guys it's a different option number. What?
3.
Okay, but basically what you want to do is menu, pick the graph option, whatever it is. Okay? And when you do that, you should be in this screen here. It should say y colon, which is going to be y equal y colon. If it does not, it means you're in a different type of graphing. There actually is different ways to graph. There's what are called parametric equations. There's what are called polar coordinates. So if you got something wonky, F3, which is the type button, don't hit it right now, but I'll show you what you get. You can be y equals, r equals, parametric, x equals constant. I don't know what conv is. I'd have to look that up. Arrow sideways, a greater than graph, a less than graph, a greater than or equal to graph, a less than or equal to graph. So if you're getting weird stuff, if you don't notice we have y1, y2, y3, y4, y6, you have to go hit type, which is F3, and then F1, which is y equals. So make sure you got that. And we're going to type a very... Is that okay, Zach? It should say y1 colon y2 colon y, right? It says equals on yours? Shouldn't. Okay, we'll pause. That's the whole purpose of this. You may have some equations. So for example, I noticed in Zach's, oh, I don't want to do that, Mr. Dueck. That was a mistake. Back to here. I noticed in Zach's, he has just a bunch of garbage there. As soon as you start typing something, it goes from a colon to an equal sign. Don't hit any of these. If you're locked inside an equation and you want to back out, you want to exit. And if you want to get rid of stuff, delete is F2. So if you want to delete an equation, F2, yeah, down arrow. F2, yeah, down arrow. And you want to be careful if you're ever getting really weird stuff. There may be, look up, there may be an equation down here somewhere that somebody put in there and it's trying to graph it and you didn't know it was down there. It's like, why am I getting this weird shape? You make, every so often, make sure everything's cleared out. So clear out anything that's there right now and then go back to Y1. These will graph 20 equations at once. More than that, you're out of luck. Although I have yet to find, aside from making a happy face, I have yet to find a use for more than 20 equations. Okay, so far? Let's type in an equation that we know and love. We're going to type in a parabola. What makes a parabola a parabola? Squared. So we're going to go open bracket. X. Now, the X button, look up. I don't know if this one works. I think the X button is right below your alpha button. It's that thing there. Let me just see if you get the same thing when you hit F5. Yeah, you get a different X. I wouldn't use that. I would use this one. This is the variable X. So X, let's move the parabola 2 to the right. How do I move it 2 to the right? -2. And if you fall behind, raise your hand and I'll pause. Close bracket. Did you find the X or not? Look up, look up, look up, look up. All of you look up. No, look up means look up. Look where my arrow is. That's the X button right there, below the alpha. Okay? Don't use this one. It'll give, this actually takes it as a function and does weird stuff. So right now you have bracket X -2, close bracket. Let's make it a parabola, squared. -4. And then to store it, press execute. No, sorry, what? X -2, close bracket, squared, take away 4. Is that all right? When you hit execute, it changes from a colon to an equal sign. And you should have the equal sign shaded in, like a little box. That means that equation is activated. What you can do, just watch and look up for a second. And when I say look up, can you actually look up? Thank you. What if I wanted to keep looking up, thank you. What if I wanted to keep this equation, but I didn't want it to graph? I can toggle this equation on and off by, let me see here, going onto it and hitting F1 select. Now it's deselected, and do you notice how the equal sign is no longer boxed in? So if you're ever wondering, Amber, why isn't the equation appearing? You may have accidentally hit F1 when you were typing and deselected it. I will select it back on again. Okay? You can toggle it on and off with F1 by the selection button. Make sure it's toggled back on. Make sure the equal sign does have a box around it. Okay? Now, there's a problem with this technology. And the problem is we have a very small screen. So what you need to do is make sure that it's graphing, because remember, in real life, this graph goes from negative infinity to positive infinity and negative infinity to positive infinity. You need to tell your calculator what area to graph. Except instead of the word area, what you need to do is you need to change the view window. Look in yellow above your function buttons. Which one of these do you think is view window? Not F3. F3 is type. Now, it's in yellow writing, which means Shift F3. So can you all hit Shift? And when you do that, all that shows up is view window, I think. Yes? Yeah. And hit F3. And what you're going to do is we're going to tell our graph what to graph from. So is there anybody that can't get to this screen? I'm going to pause. It's very important that you get there. Kyle, you're there. Logan, you're there. Okay. Now, let me tell you what this means. Okay. X min is short for X minimum, and it's saying, how far to the left do you want me to display? We're going to go from negative 10. So don't use your subtraction. Negative 10, replace X min. I don't know what you guys got. You might have a negative 10 there already. Great, I don't on mine. X maximum is how far right? Positive 10. So I'll pause here. Anybody that can't replace those? So far, so good. Scale is what you want each tick mark to be worth. Now, from negative 10 to positive 10, how far is that? 20. So what I'm going to be doing is fitting 20 hash marks on a grid this big. That works okay. If I was graphing from negative 100 to positive 100, you know what? I'd probably change the scale to go up by tens or something, because trying to fit 100 hash marks, I wouldn't be able to see between them. It would just be a big black smear. So scale is, you can change it if you need to. I usually try and pick a scale that helps, you know, 20s or 10s or 1s or 50s, something nice. Otherwise, I can just go down arrow. I have no idea what dot, okay, I do know what it means. It has to do with how accurate it's going to be. Just leave it with whatever it is. Y-min is how low your graph is going to go. Do you guys have, the older calculators, do you guys have a dot thing there? Okay, so it's irrelevant. X-min, X-max scale. Y-min, I want to go down to negative 10. So I'm going to go negative 10. Enter. And I want to go up to positive 10 for my Y max. Scale 1. Okay? Now, it turns out that this particular scale, going from negative 10 to positive 10, negative 10 to positive 10, is so common that it's built into this graphing calculator. It's called the standard scale, which we abbreviate as STD, which doesn't stand for what you think it does from biology. It stands for something in math instead. So if you wanted to, as a shortcut, I could have, let's suppose I had negative 60 there and 13 there. As a shortcut, if I just hit STD lines up with F3, it automatically goes from negative 10 to positive 10 and negative 10 to positive 10. But I always walk you through that. Have we changed our view window? Then I think if you hit execute, that gets you back to here. exit probably does too. Okay? Remember, I've already explained to you what select does. That toggles the graph on and off. Delete deletes the graph. Don't want to do that. Type lets you pick from different types of graph, which we won't get into this year. Don't remember what style or gmem does. But what I want to do is draw this, which is F6. And you should get that. Okay? The older ones, you'll probably see the cursor move. They've got a slower chip. Sorry. Yeah?
I'm getting an error.
Okay, so if you're getting an error, okay, I'll come to you in a second. Patience, young folks. If you're getting an error or a glitch, let me know. I'll pause the video. The rest of you, don't hit anything, please. Okay? What you can now do, oh, by the way, to toggle back and forth, I think F6 lets you go back and forth, back and forth, back and forth. Anyways, stay here. What you can do is you can solve a bunch of stuff on this graph. Let me say this again. You can solve a bunch of stuff on this graph. Let me say this one more time. Look up, look up, look up, look up. You can graph solve. How would I get that? Shift, because it's in yellow. What? Can you all hit Shift F5? And these are all the things your graphing calculator can find for you. What's the first one? What's a root? It's also called a zero. What's a root? It's also called something else. Roots are the x-intercepts. You know what? We there or not?
Yeah, my batteries are running low.
Your batteries are running low?
So it's like
Okay, hang on. Hang on. So one of the things we can find are the x-intercepts, or the roots, or the zeros, which on this graph are right there and right there. So hit F1. And the first root, I think it'll, on the newer calculators, it jumps right to 0, 0. Does it with yours as well, Zach, or not? It should be, it's thinking, okay? So on the older ones, by the way, it's both on the newer and the older ones, it's doing some very heavy number crunching. And so the newer ones just have a newer chip. Now, that gives me that root. How could I find this one? Try going right arrow. Okay? Okay?
oh my god.
Found them both?
See it.
On the older ones, you'll see it slowly moving. Yeah. Which it is kind of entertaining, although I like the instantaneousness, but I miss the follow the little dot because there's enough of a kid in me, follow the bouncing ball. Oscar, you're there? Yes?
Yeah.
Yes, because that didn't sound convincing. Yeah. Okay. So one of the things you can find on a graph is where it crosses the x-axis, which, by the way, those used in physics, that could be hugely important. For example, if this is a projectile, it would be telling you where it hits the ground. Like it can be used. What else? Can you go G-solve again, which is Shift F5? Did I start recording? Good. What's the next one? So that would be the highest point that this graph gets. Now, we're going to use words like domain and range. This graph's range, how high does it go? It won't have a max. If you try and find a max, it's going to say, I can't find one. But how low does it go? Right there. Who remembers from last year, what did you call that point? Begins with the letter V. So last year, you, I think, learned this completing the square method to find the vertex of a parabola. It was divide by 2, square it, subtract it. Turns out this will find the vertex for you. You have to be able to identify if the parabola opens up, that it's a minimum, or if it opens down, that it's a maximum. In this case, it's a minimum, so hit F3. And the older ones will take a while, hit F3 to find it, but the vertex is 2, negative 4, right? Yes, Pamela, I'm glad she did that. Pamela, what does yours say? It doesn't say 2, negative 4. What does yours say?
1.9999.
So there is, Rachel, no software as good as our brain. We know it's 2, negative 4. These calculators are using numerical approximation methods. And so sometimes you're going to find Sterling, maybe you know the answer is supposed to be 5, and it's giving you 4.999999999. You'll have to translate that. In particular, sometimes you'll know the answer is supposed to be 0, and it's going to give you an answer of 0.0000000000001, except it's going to give it to you in scientific notation. Physics kids, it's going to say, oh, the answer is 1.0 times 10 to the negative 20, which is 0.0000000000000000001. You got to translate these. Our brains are better than these. Okay, can you hit G solve again? What comes after min? Oh, that's y-intercept. So hit that. Turns out the y-intercept is also 0, 0. It's also a root. Is that okay? Go back to y equals. And I'm deliberately making you remember how to get there. Okay, get back to this screen. And in, everybody there? Yep. In y2, we're going to graph another equation. Okay. We're going to graph 3x minus 1. That equation there, parabola? How do you know? In fact, are there any exponents or anything? That's a line. What's the slope of that line? 3. What's the y-intercept? Negative what? Remember your y equals mx plus b? Hit draw now. And so now you should have 2 graphs. Should have 2 graphs. Okay? And what do you notice about these 2 graphs? They cross. Can you hit G solve, please, which is shift F5? What's the fancy word for cross? Intersect. So if you want to find where 2 lines cross, you hit F5. Now, it gives me the first, and I just made these up. They're going to cross on yucky decimals. There's the first one. The older calculators will take a while to find it. But look. I'm pretty sure up here somewhere they also cross, because this parabola goes up and this line goes up. Let's see if I can find the second one just by going arrow sideways. Does that give it to me? Oh, mine does. It tells me it crosses at what x coordinate? 6.85. What y coordinate? 19.5. Now, if I wanted to see the crossing point, what I would have to do is change my view window. Shift F3. And I would have to change my y max to higher than 19.65. What's a nice number higher than 19.65? 20, you know what? I'm going to go 25 just so that it, because I always worry if it's right on the edge of the screen, it might get cut off by crappy resolution. These are not, you know, HD screens or anything like that. So I'm going to change my y max to 25.
Should we do this too?
Yep. So view window, change the y max to 25. And then now if you exit and hit F6, hopefully you'll see on your screen where that second crossing point is. I hope. Yeah? In theory? Oh yeah, there it is. There it is. Okay. What else can you do under G solve? Because there is an arrow sideways. What else? So a y calculation, here's what it says. If you give me an x value, I'll tell you the y value. So let's press F1. Now, how many graphs do I have on the screen now? So now it's saying, which graph do you want me to use, y1 or y2? I think up and down arrow cycles between them. So let's use the parabola graph, y1. I think if you hit execute, enter an x value. Oh, heck, how about 3? When x is 3, y is negative 3. So this is a quick way to find points on a graph. Yours will take a while. Darian, question? Yours is like super weird?
Why can't it do this?
Sorry? Hang on.
Let me press execute. When I press execute,
Okay, hang on. Let me pause the video and come look at it.
sorry.
This will also, if you go G-solve and arrow sideways, find an X value. So if I give it I have to tell it which graph to use. I'll do the parabola again. And it's saying, okay, enter a Y value, and I'll tell you which X value goes with it. So, again, ready? Watch. G-solve. Arrow sideways to bring up these values. And I want to do an X calculation, which is F2. Then I have to tell it which equation to pick. I'm going to pick this one, so I'm hitting execute. I have to let it, because there's two equations, and it's saying, which one do you want me to use? Okay. You know what? I wonder when we're 10 high. Apparently we're 10 high when x is negative 1.74165, blah, blah, blah. And Zach's will take a while. But it gets the same answer eventually. At least it'll be accurate to about 6 or 7 decimal places. Again, it's using numerical methods to approximate this. Okay? I was going to cut and paste this into a handout, and I totally forgot, so I'm just going to have to leave the video online for the kids that are away, and you'll have to help the kids that are away kind of navigate their way through this as well. We're going to be using some of these features. We're going to be graphing some of these functions. We're going to be playing around with some of this. Gives you an idea of what we can do. Can you go back to this screen? Delete your equations, which is F2, and then yes, F2, and then yes. And then, if you would be so kind as to open your workbooks, please, to page 191. Page 191. Here is what I want to reach the point of getting to. If I say this, don't write this down. How would you solve that? Add the 4 then? The whole strategy is get the x by itself. The whole strategy is get the x by itself. I'm going to say that again, Logan, because this is important. The whole strategy in equation solving is to get the x by itself. Fancy phrase, isolate the variable. What about if we had solve? You still get the x by itself. You asked what's the opposite of squaring? Square rooting. It became a problem last year when you had this. Because now you couldn't get an x by itself because there was 2 different types of x's, and so you had to use an entirely new approach, quadratic formula and factoring. What we're going to ask this year is, okay, what if the x is here? What if it's not on the ground? What if it's an exponent? And once you allow yourself to solve those, there are a whole bunch of cool physics applications that we can now solve. Radioactivity, half-life, all sorts of stuff. But the issue is, how the heck do we get the x by itself? Tune in next week. Preview of coming attractions. Since that's your setup, we're starting off with the review of exponent laws, because we're going to be looking at exponents in a way that you've never thought of before. Here we go. Some terminology. We call this an exponent, this is the base, and the whole thing is a power. I have a handy-dandy-schmandy shorthand way of doing exponents. I try and do them in my head. I have never seen this written in a textbook, but Rachel, arrogantly, I think this is the best. In fact, you had me for Math 10. This is what I tried to teach kids in Math 10. I think my way clears up a lot of possible mistakes. But we have to review some of our exponent rules. What are the exponent rules? What's the product rule when you're multiplying x to the 5th times x to the 9th? What's the answer? X to the what? 14th. So where it says x to the m times x to the n, you can write x to the m plus n. It says add the exponents, right? What about when you're dividing? What do you do with the exponents? So this would be x to the m minus n. And you've been doing that since grade 9. Then we have, I'm going to put a little star next to this one because this is what I do first, power of a power. When you have this, x cubed to the 5th, that's not x to the 8th. What is it? Jake? It's x to the 15th because really that's x cubed times x cubed times x cubed times x cubed times it's 5 x cubeds, and now you would add the exponents. What's the short way of adding 3 5 times? 3 times 5, right? So if I was giving you the generic rule, x to the mn, I would say it's going to be x to the mn. That's times. What about when you got more than one thing inside brackets to an exponent? What if I had this, x squared y to the 4th all to the 5th? You go one letter at a time. First of all, is there a plus sign there? If there was a plus sign there, I'd have to pull out FOIL and front door bar and all that stuff. But is there a plus sign there? No? Then go one term at a time. This is x squared to the 5th, which is x to the what? X to the 10th. And it's y to the 4th to the 5th, which is y to the what? 20th. So the power of a product rule simply says this. You know what? If that exponent is outside the brackets, it goes on everything. The power of a quotient is an extension of that. Hey, if x over y is in brackets, Rachel, that m goes on everything. Oh, I added comma, y can't be 0 because you can't divide by 0, so I added that little restriction. Here are the two that you did in Math 10, which kids still get mixed up. The integral exponent rule, a negative exponent. What the heck do I do with that? Jake had me, I think, in Math 10 back in the day as well. Did you have me in Math 10? No, just Physics 11. Ben, did you have me Math 10 or Math 10? I got Rachel. Darian, I can't remember whether I had you. Yeah? So you ready? It's U4 I'm picking on. A negative exponent acts like an something. Remember what I said? And this is worth committing to memory because kids botch negative exponents all the time. First of all, Giancarlo, in my example, is there a negative exponent? Say yes. Yes. So is there a negative exponent? Yes. Get your hand away from your mouth. Taylor's going to sit up. Is there a negative exponent? Yes. Turns out all a negative exponent does, it acts like an elevator. And all it does is it causes a number to change levels. And the exponent becomes positive. Now, obviously, I can't leave it like that. What should I put on the top instead of leaving it blank? Now, why do I explain it that way? Because I think that also makes this one much clearer. Do you know what a negative exponent acts like? It's going to cause it to change levels. Right now, the y to the negative 6 is on the bottom. Where will it end up? And become positive. And I don't have anything left on the bottom. It also really explains the combination questions. X to the negative 3 over y to the negative 7.
Swap floors.
A negative exponent, Pam, acts like an elevator. That's all it does. And that's a bad math explanation, but I'm telling you it's a good analogy because the x cubed is going to end up on the bottom floor. And by doing that, when you change floors, the negative it vanishes. And the y to the 7th ends up on the top, and now we're happy. And now we're happy. So the mathematical definition, x to the negative m equals 1 over x to the m, but you can make a little note here. Elevator. There's dumb analogy number 1. And yes, my 4 students from Math 10, I'm going to pick on you for this next one as well. Rational exponents or fractional exponents. What the heck does x to the 2/3 mean? Darian, for a candy, say it loud, say it proud. Flower power. Ready? Look up. Here's Mr. Dueck's dumb way of remembering this. We'll write this down neatly in a second, but just watch. I remember flower power because, first of all, every flower has both a flower and a root. Has both a flower and a what? There's going to be a root in your answer. Ooh, yeah. The x goes there. Darian, do you remember the stupid little chant or mantra or rhyme? The flower goes to the, and the root goes to the. And what I imagine is this is the flower, and that's the root. Flower power. Because everybody seems to be able to remember, Zach, that there is a square root thing, but it's what number goes where. That's the only problem that I find when I taught this to Math 10 kids. Where does the 3 go? Where does the 2 go? Flower power. So if you imagine that this looks like a flower, flower to the power, root to the root. You can write that down neatly in some way if you want to, however you want to remember it. But I use that all the time. Now, there is a consequence of that. There's a consequence of that. And this is worth, in this unit, having at your fingertips. And I'll show you this consequence. Right? I'll just pause because people are writing this down. The consequence that's worth having at your fingertips is the reverse of this. Square root of x is the same as x to what power? First of all, what's the exponent sitting right there? It's invisible. What's the flower? That's the root. Now, square root, there is a number technically there, but because square root is so common, we never write it. It's understood that it's there. It's worth this unit, Jordan, when you see root x, that's x to the 1/2. Or when you see x to the 1/2, that's root x. And you should be able to flip back and forth, almost like changing clothing. Or the other big one is this one. What's that? X to the what? To the 1/3. X to the 1/3. So, now that I've got all this written down, x to the m over n, if I use flower power, is going to be the nth, boy, that's a terrible root, Mr. Dueck, nth root of x to the m, or the nth root of x. Aren't those the same thing, Mr. Dueck? It's saying you can take the root first and then to the nth power, or you can take the power first and then do the root. I can see looking from the back. Let me make that larger. Yeah, Liz, that's for you. I can make this a little bit neater. And by writing it this way, I'm saying, Alyssa, you can either do the exponent first, then take the root, or you can take the root first, then take the exponent. I usually do this because if I take the root, numbers are smaller, and then I'm good at exponents in my head. Okay. The third thing. Can I pause for one? Can you open to the back cover of your workbook? If you're not using the workbook, You're just going to write this down as you're taking notes. The very back page where it says there's a blank page for notes, I think it's page 12 or something dumb.
Page 12.
Okay? Can you open to the very back page? The third thing. It is worth having some basic powers memorized. And those of you that have me in physics know how much I hate memorizing stuff, which means if I am telling you it's worth memorize, ding, 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 it's probably going to be really important. And by memorized, Sterling, I don't mean being able to regurgitate them. What I do mean is if you see one, you recognize it, which isn't quite the same as memorizing. Here's what you should know. You should know, you guys with me? You should know 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th. I'm going to write the answers underneath each one of these. What is 2 to the 1? What's 2 squared? 2 cubed. 2 to the 4th. 2 to the 5th.
64.
Hey, keep going. What comes after 64? 128, then 256, 512, 1024, 2048, 4096, 8192, 16. You keep going. Those ones, what I mean by memorize, Oscar, if you see a 32, you should say, hey, I know that's 2 to something. And then you can kind of guess on your calculator. But if you don't know that it's 2 to something, you'll never be able to guess on your calculator. You should be familiar with you'll notice I don't take it quite as far with the 3s as the 2s. What's 3 to the 1?
3.
Pam, what's 3 squared? 3 times 3 is? It's 9. I'm glad you did, because that's by far the most common mistake, and I see it all the time. I see 3 squared, 6. Don't do that. 9? Or is that a German saying? No, I never get, okay. 3 cubed. 3 times 3 times 3, or 9 times 3.
27.
27. 3 to the 4th, which, by the way, is really 9 times 9, because it's 3 squared squared. Yeah, clever boy. 81. 3 to the 5th. You can multiply 81 times 3 in your head, because it's 80 times 3, 240. 1 times 3, 3. It is. And again, do you have to have these at your fingertips? What I'm saying, Logan, is if you see a 243, ding, 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 I think that's a power of 3. Not 2, not 7, not 5, 3. You should know and you'll notice I don't go as far each time as the numbers get bigger, because the numbers get bigger. 4 to the 1. 4 squared. 4 cubed. Because it's 16 times 4. 4 to the 4th. It's 16 times 16. It's 256. I'll be honest. You probably won't see that one. The one that's a little nicer to do math with is your 5 times table. So you will need to know, oh, change colors, Mr. Dueck. The first 4 powers of 5. And again, Amrit, although I said the first 4 powers of 5, I'm going to assume, you all know the first one. Everybody knows what anything to the 1 power is. Okay? So, speaking of Amrit, what is 5 to the 1? Thank you. 5 squared, don't say 10. 5 times 5? 25. All right, what's 5 times 5 times 5? What's 5 cubed? 125. 5 to the 4th is 25 squared, 625. By the way, do we notice any kind of a pattern? What do all the powers of 5 end in? So if they tell me something's an exponent and it ends in 5, I'll check with the 5s first before I go look anywhere else. You really don't need to know much more than that. And again, Logan, let me emphasize, by no, I mean if you see it, clue in it's 6 to some power. Speaking of, Logan, 6 to the 1. Thank you. 6 squared, Logan, my friend, 6 times 6. See, by the way, most of you have your squareds memorized, so you don't have to have those. You got them already. All right, 6 times 6 times 6. Double check me, but I'm pretty sure it's 216. Okay. Hey, what do we notice the exponents of 6 end with? 6. Wow, that's convenient. As the numbers get bigger, I'm going to expect you to know fewer. In fact, Ashley, I would argue you probably already have these two. What's 7 to the 1, Ashley? And what's 7 squared? Yeah. Seven cubed, I just remember, I think it ends in a... It's 49 times 7. I always figure it out. It's 343. Double check me, but I think it is. Okay. By the way, I calculate. I don't have that one memorized. I go 50 times 7 minus 7. It's 343, which is why I didn't include it in the blank. Any kind of a pattern here? No, but I'm going to assume you got 7 times, 7 to the 1 and 7 squared already memorized. Rachel, what comes after 7? You should know this one and that one. Rachel, what's 8 to the 1? What's 8 squared? 8 times 8. 64 is right. Which, by the way, also appeared in the 4 and in the 2. 64 is an exponent a number of different ways. What number comes next? After 8?
9.
Yes! Germans? Okay, fine. Tough audience. 9 to the 1. 9. That wasn't bad, Jordan. Come on. Jordan, what's 9 to the 1? Yeah. Oh, fine. What's 9 squared? By the way, if it's a power of 10, what will it end with? A 0. So I'm not going to go further. Those are the big ones. And in particular, if I'm making up test questions, Logan, and I'm using exponents, it's going to be 2s, 3s, 4s, and 5s. Maybe a 6. Not much more than that. Okay? So be familiar with those. And again, Alyssa, what I mean by be familiar with them is, hey, if you see a 27, you should know it's 3 to something. And now you can just guess on your calculator. 3 to the 1, 3 squared. Oh, it's 3 cubed. Back to our notes on page 190, whatever it was. So, Mr. Dueck's handy-dandy way to simplify exponents. Up here where we have the rules, can you put, please, next to where it says power to a power, can you draw a big, or put a big number 1? I always do that first. Then the rule that I always do second, elevator. By doing it that way, what you're getting rid of is dividing by a negative exponent where you have to deal with a, is that a minus? I never deal with it. I refuse to. I got better things to do with my brain than confuse myself. So you ready? Example 1 says, use the exponent laws to simplify the following. I'll zoom in for Alyssa in the back row there. X squared times x squared. This is actually math 9. X to the 5 or 6? 5th, with conviction and authority in your voice. 5th. Now, I'm going to show you how I do B. I probably do it differently from you. The first thing I look at in B is there a power to a power? Are there brackets with exponents outside? No. Then I look for elevator. Are there negative exponents anywhere? No. I always check that first. And then what I say is to myself, Chelsea, hang on, let me pause the video. I've got a little phone ring. Chelsea, my joy, how many x's on the top of that fraction grand total? Say 6. How many on the bottom of that fraction? How many left and where? 4 on top. Because they're 2 are going to cancel with 2 other ones. I don't actually divide. I always say how many on top, how many on the bottom, how many left, and where. And you're going to see why in a second. 4 on top. C. C. Power to a power. Oscar, x to the 5th to the 4th is x to the what? Is it? Which one? Yeah, in fact, you know what? If you had said 9, I would have said 9! I mean, no! Right? Come on, that was pretty good.
That one was good.
D. Is the exponent, sorry, are the variables inside brackets? Is the exponent outside brackets? It goes on everything. There's power to a power. Goes there, goes there. It's going to be x cubed over y cubed. E. Is the exponent outside brackets? It's going to go on everything. The 3 is going to go on there and on there. It's going to be 3 cubed x cubed, except Mr. Dueck just told you it was worth memorizing some exponents. 3 cubed is very unwieldy. What is 3 cubed? And if you don't know, you can go to your calculator. You know what? I would prefer to write it like that. Okay? Let's put it all together. It says, simplify, write each expression without brackets and only positive exponents. I can do that. First one, A. First thing I look for is there a power to a power? Is there? No? Then elevator. Sure, Dom. Then, is there any more simplifying I can do? Nope. B might look scary, but I'm going to tell you, you can do it in one line. You ready? First of all, in B, I see 2 terms, 2 brackets. Are there exponents outside any of the brackets? No? Then what I'm going to do is I'm going to write each term one at a time, putting anything on the elevator as necessary. That first 4, is there a negative exponent on it? Well, then rewrite it. That x cubed, is there a negative exponent on it? Well, then rewrite it. That 2, is there a negative exponent on it? Then rewrite it. I'll put a dot to show that it's times. That x to the negative 4, oh, did I say negative 4? Put it on the elevator. It's going to end up down there. I said I could do this in one line. We're not going to show any more work. Laura, the first thing we're going to take care of is numbers. Can you see on the top I have 4 times 2? And no numbers on the bottom? There's going to be an 8. Now you ready? Laura, my joy. How many x's on top? How many x's on the bottom? How many x's will be left and where? I think 1 x will be left where? And that gets rid of dealing with negative exponents. You could go, oh, it's going to be x cubed divided by x to the 4th, which is x to the negative 1, and then you could rewrite it and then say x to the... You know what? I can avoid negative exponents almost totally by doing it this way. C. Right? It's going to be, because I always do power to a power first, Chelsea. I take care of any exponent outside brackets first. It's going to be 2 cubed X to the Oscar, what? What? With authority in your voice. Thank you. If you left it like that, I probably wouldn't mark it wrong, but 2 cubed I can write nicer. What is 2 cubed? D. Yep. Quick like a bunny. I know I've been talking a while. The graphing calculator thing took a little longer because all the walking around helping people. Is there an exponent on the 5? I guess a 1, rewrite it. And then it's going to be power to a power. So times 3 cubed x to the 6th. Any negative exponents anywhere? No? Well then, what is 5 times 3 cubed? It's 5 times 27, I know that. You got calculators, go. Come on, people. 135? E. Are there exponents outside brackets? Is there power to a power? No? Okay, then the next thing I look for is elevator. That 5 stays where it is. What about that x to the negative 3, Kyle? Did I say negative? So where's it going to go? And become positive. What about that x to the negative 2 that was on, well, did I say negative? Where is it going to end up? We're not quite done. Kyle, there's a 5. How many x's on top, Kyle, grand total? How many on the bottom? How many left where? That's a better way than dealing with negative exponents, in my opinion. I think it's more intuitive. It gets rid of the whole minus minus thing that can happen sometimes. Where doesn't it work? Well, it works everywhere if, like me, you're comfy with fractions. It doesn't work great if you're not good with fractions, like F. Is there power to a power? Nope. So start rewriting terms, looking for elevators. That 12, stay or down below? That b to the negative 1/2, stay or down below? That 3 that's on the bottom stays. And that b that's on the bottom stays. There's my one line of work. In terms of numbers, I got a 12 on top and a 3 on the bottom. What is 12 over 3? 4. Will the 4 be on the top or on the bottom? On the top. If it was 3 over 12, the 4 would be left on the bottom. But there's a 4. How many b's on top grand total? It's a trick question. Oh, so all the b's are going to be on the bottom. How many b's are on the bottom grand total?
1.5.
What's a better way to write 1.5? Right? You don't write an improper fraction as an exponent. By the way, you could flower power that if you wanted to. It's the square root of b cubed, but it didn't say to do that in the instructions. A couple more and I'm done. Can you wait till Pam gets back? A couple more and I'm done. It says, without using a calculator, find the exact value of the following. In our heads, A, is there power to a power? Well, let's elevator it. Who remembers what's 2 cubed, which is 2 times 2 times 2? 8. Okay, hustle back, Taylor. If you want to wait for 3 examples, if you can, great, but if not, that's fine. 9 to the 3 halves. Is there power to a power? No. Negative exponents? Elevator? Oh, what's this one, Darian? Oh, this is going to be, there's going to be a root because there's a root for every flower. The 9 goes there. Where's the 3 go? Here. Where's the 2 go? Well, technically here, but if you leave it blank, we know it's square root. This is the square root of 9. Square root of 9. This is the square root of 9. I want the answer. Square root of 9. Stop saying that. This is the square root of 9, which is
3
cubed, which is
27.
okay. This is what I meant by it's easier to do the root and then the exponent. You could have gone 9 cubed, which is 729, and then square rooted that. It's a little awkward. Can you wait for 2 more minutes? Hey, what's anything to the 0 power? Not 0. Let's put it all together. 16 to the negative 1/2. That's the same as 1 over, which is the same as, oh, you know what? I'm not going to rewrite it. I said it was worth knowing interchangeably that 1/2 as an exponent is the same as doing what? This is 1 over the square root of 16. Hey, your homework is numbers 1 to 3. Sorry, it took a little longer. I was hoping to give you 15 minutes. I'm giving you 9 minutes to work on the homework.